The kinetic molecular theory is based on the idea that all particles are constantly moving. That's what the word kinetic means, is movement. And it can be applied to a solid, a liquid, or a gas. But in this case, we're mostly focusing it on gases because there are 5 points to the kinetic molecular theory that we use to assume the behavior of all gases. And if a gas follows these 5 assumptions, then we say that it is an ideal gas. But of course, ideal gases are completely imaginary, don't really exist. Real gases just kind of, sort of behave like ideal gases. So the first part of the KMT is that gases are tiny particles and they're super small apart, or super far apart. The biggest thing that you guys need to get out of this is that most of the volume is empty space in a gas, and that's why gases can be compressed. And then the second one is that all of the collisions, let it get caught up here. All of the collisions between particles and the container walls are what are called elastic collisions. And that's basically where, most of the time whenever you drop a ball on the ground, it'll bounce back up to about half the height. It depends on how bouncy the ball is. And then it just kind of keeps doing this until eventually it's not bouncing at all anymore. Well, in a gas, the assumption is that when a gas particle hits an edge or another gas particle or something like that, it's going to bounce off with the same energy that it hit. Then we have that particles are always moving, and that's kind of all I can say about that one. The biggest one is that there are no forces of attraction or repulsion. In that the gas particles are not supposed to stick together. They're supposed to just hit each other and bounce off. But as the temperature of a gas drops, then the particles are moving more slowly, and so they do actually have forces of attraction and repulsion. But again, these are assumptions of an ideal gas. And then the last part of the kinetic molecular theory is just basically stating that the kinetic energy is dependent on temperature, or the temperature is dependent on the kinetic energy. And this is just a little formula relating the mass and the velocity of a particle. So at the same temperature, a heavier particle will have less velocity than a smaller particle, which is what is being stated right here.